Okay, I think it should be working now.
So, chain rule. Some insider source has told me that you guys have been finding this a little difficult.
No, I'm just really bad at simplifying shit.
Oh, or that. I had a hard time with chain rule when I first learned it, but it's not that bad. It's just like hard to wrap your head around. So I think the way you guys learned it was through you, right? So, and then can you give me a chain rule problem, like a simple one to start off with? Like just one from here.
Y is equal to 1 minus x whole squared.
1 minus x whole squared, right.
Write it in terms of y, please. At the end, when you find it, like, write it in terms of y.
Oh, okay. So, you guys did this with u, right? So what it is I say 1 minus x is equivalent to u. Therefore, this is equal to y times y equals u squared, right? And so the derivative of y, which I'll try as y prime, is going to be 2u times u prime, because it's derivative of the outside, which is this like function squared, with respect to the inside, and the inside is 1 minus x. It's like a layers with like an onion, like an ogre. And so the thing about chain rules, it's always just that. Derivative of outside with respect to the inside over and over again. So if I have 4 different layers, I'm just going to keep doing it until I get to the very last layer. Which you will get tests like that, where it's like secant squared of tangent x plus cosine squared of x to the power of 5 or something. You will have to differentiate those. And for that, just keep remembering derivative of outside with respect to the inside. But anyways, this one becomes 2u times u prime, right? And so u prime is equal to, well, derivative of 1 is 0. Derivative of negative x is negative 1. So it's just that. So it's going to be y prime equals to 2u times negative 1. So then, y prime is equal to 2. We know that u is 1 minus x times negative 1. So it's just going to be negative 2, 1 minus x. Does that make sense, Ananya?
No. I did something wrong. But
What
okay,
did,
yeah, that makes
what did you do wrong?
This is what I did.
Where? Which?
This is what I got from my answer.
Because that, you did 1 over 1 minus x squared. I just did 1 minus x squared. They're different.
Oh yeah, okay.
Okay, yeah, anyways, I won't cut that out.
You know something?
Okay, sorry, my brother came in for a second. But, so another way to look at chain rule is, so, dy over dx, right? I don't know if you guys seen this notation before, but dy over dx. It's another way of writing y prime, right? And essentially what this means, if I have, dy over dx, right? What this means is the derivative of y right, with respect to x. With respect to x. And you can also say this is like in terms of x. Think of it like that. Does this make sense to you? Like this notation?
Yes.
Right? And so chain rule, if you think about it. Shit. You guys didn't see that. Chain rule, if you think about it, is just doing that a bunch of times but switching the terms. So if I introduce u, right? And so I need to solve for dy over dx. So I'm going to say, dy over dx is equivalent to, the derivative, hold on, let me like choose a good color. The derivative of, okay, hold on. So derivative of, that's not the right color, oh my gosh, sorry. The derivative of y with respect to u multiplied by the derivative of u with respect to x, right? And you can see that in the problem we did here, because the derivative of y with respect to u is just u squared equals y, right? So the derivative of y, dy over du, is just going to be 2u. That's simple power rule. You guys learned that. So that's going to be this. But then you also have to do derivative of u with respect to x, which is just u prime. In this case, it was just -1, right? And so the crazy thing about chain rule, the reason why it's called a chain, are you ready for this? Are you ready for this? It makes a chain. That's what chain rule is.
Wow.
Does that make sense to you?
Wow. A visual. Yeah.
Does it make sense? Does it make sense why that's the case?
Yeah.
Okay, let's do a couple of practice problems. Cause I don't.
Looking at me like she's looking at me so concerned. The expression on her face is one of like disappointment.
Just remember this. I feel like this will help a lot with like conceptual understanding. Can you give me a practice problem?
Oh, just like the one I gave you before.
Yeah. You can make it a little harder this time.
Okay. Actually, Miss Wade did that with us. Okay.
Yeah.
Just do x cubed plus 1
Okay.
over the square root of x.
Over square root of x, right? Now the first thing I'm gonna do is I'm gonna rewrite this as x cubed plus 1 to x to the 1/2. This is product rule. I want chain rule. Well, I'm sure it has chain rule in it somewhere, but I want product rule specifically.
You mean chain rule specifically?
Fuck yeah, well, chain rule
Okay.
specifically.
2 root x.
Yeah, just isolate. Yeah, hold on. 2 root x
Plus 4.
plus 4
All to the power of 7.
to the power of 7. Okay, cool. So in this case, u is always going to be what's on the inside, because, you know, layers. Inside versus outside. So let's assign our u equals to 2 root x plus 4, right? And let's say this equals y. So then, y equals u to the power of 7. Now then, dy over, we know that dy over dx is going to be dy over du times du over dx, right? And so my derivative of u is going to be 7 u to the 6. That's just power rule, we learned that. Times the derivative of u. And my u is going to be, well, we have this right here, 2 root x plus 4. And you can write this as 2 x to the 1/2 plus 4. And so when you take the derivative of that, it's going to be, you can take the constant out. The derivative of root x is 1 over 2 root x. So it's just going to be 1 over root x plus 4. So then you can multiply this by this. I'll do it times. And so that's going to equal 7 2 root x plus 4, because we sub in u to the power of 6, times 1 over root x plus 4. You could simplify this some more. I'm not going to, because I'm sure that's basic algebra. You all know how to do. But that's the basic idea. Okay, can you give me like a harder one now? Like one that you might have struggled with a little?
You want to prove the chain rule by induction?
Hell no, dude.
Actually, do you want to prove 1 plus x to the power of -1 by induction?
I don't want to do anything by induction. Just give me a chain rule problem.
Okay.
Like a harder one though.
That was pretty. Okay. 2x
2x.
root x
2x root x? Okay.
plus 8x
Mhm.
squared. All squared. Or no, all like to the power of 4.
Power of 4? Okay, cool. So, first thing I'm going to do is I'm going to rewrite this as 2x to the power of 3 over 2 plus 8x squared, because fractional exponents are always going to be easier to work with, because then you can do power rule instead of having to do product rule. And if you're wondering about that, it's x to the power of 1 times x to the power of 1/2, which is x to the power of 2 over 2 times x to the power of 1/2, so that's just going to be x to the power of 3 over 2. Right? And so then I'm going to write u equals to 2x to the 3 over 2 plus 8x squared. It's always what's on the inside, pretty much. All of the time, u is what's on the inside. Right? And so then, y is going to be equal to, since it's to the power of 4, it's u to the power of 4. So then, dy over dx is equivalent to 4u cubed by power rule multiplied by the derivative of my u, which is like this thing right here. So let's take the derivative of that. First term, 2x to the power of 3 over 2. That's simple, right? That's going to be 3 over 2 times 2x to the 1/2 by power rule. So that's going to be 3 root x. Now, 8x squared is also pretty simple. That's just going to be 16x by power rule. So it's going to be 3 root x plus 16x is my derivative fully. So I'll erase that and I'll write 3 root x plus 16x. And notice here, this is my dy over dx. This is my dy over du because it's the derivative of y still with respect to u. And then this is my du over dx because this is the derivative of my u, which is over here. And again, that all cancels out in a chain. This is not really a chain. The way Miss Sang taught us when she subbed for us was like an actual linked chain, but you get the idea. Right? And so then just simplify, well, first, always remember to sub back in u, because you'll get like, it's a common mistake a lot of people make. I used to make it a lot, but always remember to sub back in, because otherwise your answer is technically incorrect. Alright, cubed. And yeah, there's your answer. Alright, Nanya, can you give me one more?
4. 4 cube root of x.
4 cube root of x, I'm gonna write that as x to the 1/3.
Minus 7x squared.
7x squared.
All
To the power of?
4.
Just 4?
You want to make it 10?
Sure, let's make it 10.
Okay.
Because it really doesn't matter. It doesn't make a difference. I'm gonna not color code this one because it's too much work. I hope you guys get the memo anyways. So u equals 4x to the 1/3, or 7x squared. You should know the drill by now. Let's just take the derivative of u right now. So I'm gonna write this as u prime is equal to what? 4/3 x to the negative 2/3 minus 14x. So we just have that, right? So then if y equals to u to the 10, then dy is going to equal to 10 u to the 9 times u prime. We already know what all these are, so now all we can do is substitute. So then 10, 4x to the 1/3 minus 7x squared to the power of 9 times 4/3 x to the negative 2/3 minus 14x. And, simplify, but there's your answer. I hope that helps. This one's a little all over the place, but you know what? That's okay.